The gentleman is saying hello to one of the speakers, says the interpreter. Now, we are going to introduce this session. Now we just have three speakers. One is missing. Irene Lopez's presentation, she apologizes. She works for the Paris University, and it seems like that she's had difficulties to come here today, and she's sent me an email this morning. So we will have, this is a hot topic, yes, and it is an issue where a lot of active policies have been undertaken by countries like Spain, but namely by the European Union as a whole. We all know the research program to raise awareness on technology, the so-called ambience existing living, with the cooperation of the EU and member states in a multilateral fashion. We are going to talk about active aging because of the endless numbers of products, goods and services in this regard, but also because of the increased number of needs by the aging population, by the elderly, to give them goods and services, but especially quality goods and services. This is not only about surviving, is it? It's about having a reasonable life by fostering the inclusion in the society, so that they have an active role, not only from the personal and family point of view, but also from the social point of view. So I won't really go into detail. I don't want to bore you to death, because it's not my turn. I'll just give the floor to my first speaker, called Enredate. Be tangled is the translation into Spanish. Tangle yourself up. For the participation of volunteers and elderly people. This is a joint cooperation between Vodafone and the Red Cross. And by way of introduction, Ana Peñalver Blanco. She's a technical engineer in telecommunications by the Polytechnic University of Madrid. She's an expert in universal accessibility by the Oberta University of Catalonia. And since 2008, she works as the project director for the Textos Foundation in joint cooperation between Vodafone and the Red Cross. She has a very strong background working for Vodafone Foundation and also the Red Cross. She has led numerous paramount projects, the existence of accessible mobiles for gender-based violence victims, and the implementation of services for social intervention and the use of methodologies based on the ICTs. So without further ado, Anna, please, you have the floor. Thank you. Hello, good afternoon, ladies and gentlemen, and thank you very much, Ramon, for the introduction. Can you please display my slides on the screen, if you don't mind? Thank you, thank you. Despite my CV, well, I'm just Anna. I work for the Nexus Foundation. It is a joint cooperation between Red Cross and the Vodafone Foundation in Spain. As you can guess, the work we do at the Texas Foundation aims at creating the best excellence, technical excellence, combining this with the background the Red Cross has. We work mainly in the different areas that you can see on the screen. The work by the Red Cross within houses, promoting communication, and in case of the Texas Foundation, we work with elderly people with disabilities, and with gender-based violence victims. And our final goal is the promotion of their autonomy so that they can become self-dependent. If I asked you here, how many of you would like to age? Of course, you'll raise your hand, okay? Age in quality terms, everyone will raise their hands. If I ask you, how many among you have a mobile phone on our pocket? Of course, you will raise your hand, wouldn't you? How many among you have a laptop or a PC at home or a smartphone or a tablet? Of course, you will raise your hand. We would like to give you a little bit of context. People aging, we're all doomed to be older, but we are all going to use the technology that surrounds us. The main goals of this project is to promote exchange and virtual communication for the elderly in response to their needs, their support, their community support by fostering communication between the elder and volunteers by means of the social media. As I said before, we work in the field of the Spanish Red Cross. It is one of the pioneers that request more care. It is based on audio communications. And when we ask users and the beneficiaries of the service, how would you improve the Red Cross work? How do you think we can improve better service, better quality service? How can we go even further? They said, we'd like to see the volunteers, not only to hear them. So we improved the system. So now we have video communication. The elder people now have direct communication on the screens or their TVs. So after running a few pilot tests, we steadily improved the services provided by the Spanish Red Cross. In one of the sessions, the users proposed that not only they wanted to talk to the people at the Red Cross, the agents, the people on the sector, and the volunteers, why don't you let us talk to ourselves, among ourselves? So little by little, that started to be a reality. We created a service that was called Enrédate. Chat about it, tangle up. They were monitored in order to detect any incident between the relationships. By using devices connected on TV, we ran a pilot test in 2010 with around 100 people in 17 regions and different autonomous regions of Spain. We realized that there was a digital network, but now using tablets instead of TV screens, and this was the entire background of the project. It's like a labyrinth until we arrived in 2015 when Enrédate is a service which is provided by the Spanish Red Cross. This is a little bit of detail of how this system and service works. Enrédate is an app that is downloaded from the App Store. You can access from laptops and also from tablets. The Red Cross volunteers can access this app from their computers, and the users can also use their tablets or laptops. So it's been a web-based application, internet accessible application, and the other one can be downloaded from the Android or App Stores. In the entire process, we have been bearing in mind the opinion and feedback of our users, and also the opinion of the people, the volunteers that are working with us. They were constantly monitoring the entire process, and that's why we have been collecting information, doing different interviews, focus groups, and also different fillings of forms until we arrive at the final product. But be sure that there is a lot of protocols with the contribution of social sector professionals. And finally, we have a product, and the results of the pilot test were very, very positive indeed. and therefore that led us to provide it as a Red Cross service. This is the work we did on the tablet device with different improvements in terms of usability, in terms of the interface, thus allowing multimedia contents to be seen, and everything could be handled by the Spanish Red Cross. We've incorporated a lot of novelties, not only video conferences that you can find on the internet, but we incorporated other aspects, and we had a cooperation by our volunteers, because the volunteers and the users could detect alarm situations and emergency situations of other people on the network. For example, someone hasn't received the call, they called someone, and when they saw them, they were wearing some scruffy clothes, to be honest. So little by little, we have improved our system, and that created a whole network of users, and we've shared this with other departments in the Red Cross, and they wanted to use this with other target groups, not only with the elderly. I'd like to display a video now.
This is a participant in the pilot project, and currently this person is a user.
Pues mira, yo me llamo Yesida.
Es Lesida. Me gusta que me llamen Lesida.
Tengo 90 años.
Mi nombre es un poco raro.
Pues sí, vivo sola desde hace ya casi 15 años. Y estuve casada 53. Tengo 2 hijas, una de ellas vive en el extranjero y otra aquí en Burgos. Yo prefiero vivir sola, estoy mejor en mi casita mientras yo pueda defenderme sola, ya sabes. Yo me suelo levantar por la mañana a las 8:30 o las 9 de la mañana. Me aseo y luego pues entonces me hago mis labores de aquí de casa y entonces me voy a mis actividades. Unas veces me voy a la Cruz Roja y entonces pues ya me pongo a la tarde a comunicarnos con los compañeros que estén abiertos en el programa de Enrédate. Enrédate es un programa muy bueno para las personas mayores. Yo creo que sí que
I think that is really a good thing for us to be able to speak to other people. And I think it's great because we even make friends. There's a really nice lady from Madrid called Mari Carmen. And now we've become friends. It's like we've known each other all our lives. I really feel happy when I see I can do that. When I've been able to help someone, a friend or someone else, I feel really satisfied. 94% of elderly persons who have used the Vodafone Spain Foundations gave it a very high recommendation. And it's true that this challenge was very important until we decided to go with a communication model that was decided, and we had to adjust the bandwidth properly. It was a little complex, but truly at the end it's all about introducing these new technologies that can be useful for people in an environment that is safe, where they can be. And lastly, I'd like to say simply that when we show this project to different groups, we've often been asked if other groups could use it as a tool, like in the people who take, or the caregivers of people. We have a pilot project in Barcelona with 80 people who are getting training, and this is done through the tablet, and trainers and students are connected there. And lastly, the most recent case we've had is with The Children's Hospital at Red Cross, there are several children using this same network, and it's also supervised by volunteers. We continue to work, and on our journey we've received several awards for our initiative, and this is our contact if you'd like to visit our website. Thank you very much. Thank you for your interesting presentation, Ana. Now we'll have a brief time for questions and answers, suggestions, any worries, concerns that the audience might have. I'm sorry, the speaker's not using the microphone. If they're taking the microphone. Are these people at home? I understood that this lady in the video goes to Red Cross and meets other people who use the tablet. Are some home and some at Red Cross? Well, in the video, what the user was saying, she's at home and uses her tablet there to talk to other persons at Red Cross, but that doesn't mean that she cannot go to Red Cross and meet with some of these people directly. This is all about a tool that can bring people together. It's a catalyst, and it can foster personal meetings of individuals. That's part of the great success of the project, that people who start knowing each other through the tablet can later meet personally and become personal friends. Well, what about persons who can't leave home or don't want to leave home? This is an easier way for them to relate to other people. Yes, and that's the role of volunteerism, is something we have introduced to supervise somehow these relationships, because apart from the numerical figure of how many people are connected, which is something we can limit, we do have all the social analysis of the situations. And Enredate is a tool that supports other programs that Red Cross has. It's not always used for every program and by every person. Certain profiles and different activities can use it, and those are followed up by us, because otherwise everybody would be connected all at once for forever. Any other question? So we'll move on to the second speaker of the afternoon, Juan Pavon Mestras. He's a doctor in IT from the Polytechnical University of Madrid. Before, he worked for Alcatel in France, Spain, and Belgium, and Belcor in the U.S., and especially in multimedia development and networks, wideband. He's a professor at the University of Complutense of Madrid in software engineering and artificial intelligence. He's managed many international and national development projects for multi-agent systems, personalization of services, management of knowledge in intelligence environments, simulation of complex systems, and now we'll turn the floor over to Juan. The name of his presentation is Social, an 3D environment for all, simulation of ALL solutions. Well, I'm going to talk about the multidisciplinary work that my team has been carrying out. We have specialists from the nursing and sociology departments involved, as well as IT engineers within the scope of this workshop. I think this fits in well. People who all want to age better and have greater autonomy as they grow old. And this is in line with the European guidelines we have for the AAL, which I think you all are familiar with. One of the problems we have when you want to try this type of application, let's imagine if we want to develop an app to see. Can you turn the sound down a little bit, please? We'd like to develop an app to see how someone falls. One thing that happens sometimes, this was in the U.S., we had Chinese students falling down constantly. And it turns out that at the end we've got stairs here, but it's hard to try the apps out because when you fall this way, you don't do it in a natural way. It's a forced fall. And the developer might be developing an application and need to try it out with someone falling 1,000 times over and over again, repeatedly. So I can't have someone falling 1,000 times down the stairs. Like in this case, I don't think that would be appropriate. We'd all end up with different problems, additional different health problems. But to do this, what we decided was to use what we call living labs, virtual living labs, which are environments that are simulated in 3D, and we can do this sort of thing there. This new concept came out. It was published by us about a little more than a year ago. The basic idea behind it is that a living lab is an environment where we can experiment with apps like this type, but it's simulated. It's a simulated 3D environment. There are several advantages, and one is that we can repeat as many times as we want a fall. We can define many different scenarios in a living lab. Usually a normal one would be very expensive. We'd have to have a lot of physical resources, but in the living lab, it's all virtual, so it's a lot less expensive. We have to make these simulations as real as possible, and I'll tell you in a minute about this. We also want to try and capture requirements that certain actors have. In our project, we're related specifically to people with Parkinson disease. Let's imagine that we have a family member who we hope he'll be able to live autonomously and adapt his home. We have to include a lot of sensors and control mechanisms in his home. And if we go in and set this up, we set up all these devices, but then they don't meet the person's daily needs. The person might also feel that there's some intrusion in his home with all these devices. Some people don't want cameras. They would rather have other types of sensors. So we always must find solutions that are very specific to each type of user. And depending on his degree of autonomy, we have to see who he can, who the person lives with, look at many cultural aspects of the person's life, and it's complicated. So what we want to do is try to test these solutions in a virtual living lab, and then once we've done that and that we see that everything is properly configured and working well, we can take it into the home and further develop it. Here we have a couple of tools that are complementary. One is the simulator for 3D, and it's called PHAT, P-H-A-T. Then we have we have the language to specify PHAT. First here we've got the ability to use, by using a game environment, We can simulate physical situations and create avatars who will represent the people. These avatars can have devices. Even here we have one who has an Android phone. The Android phone that we're developing will execute the real application, and we'll execute that here. It will be able to be tested using physical events that would occur through the person's movement. Here we can see it. We've developed an application to avoid falls, and here we see the person has fallen, and the signal that is received by the sensors in the telephone, the application, the Android application shows what we see up above on the right. And let's imagine that we've tested this after development and seen that the algorithms work correctly, but imagine someone with Parkinson's, as in this case. If you look closely at the image, you see that the sign is not so clear, the message that's going to the app. So it seems that our app is working perfectly, but in the real world, things are not always that way. If you've tested an Android phone, you see that the sensors have a lot of noise. And our situation shows us that the signal fluctuates a lot. The application sometimes often fails, and falls are detected, false falls are detected, falls that really don't occur are detected. And we can change the algorithms to correct this, but at this point in time, since we can replicate quite realistically the signals of the real sensors, we can test this until we really reach a good valid point. And that's the idea behind what we're doing, basically. And when you are developing, there are many testing phases and a lot of refactoring codes and retesting, and we can do that here with our usual tools. But when we developed this, we found some challenges that were new. Among these was developing more complex scenarios. We don't just want to use the same scenario. We not just see the scenario of the home, for example. We want people to be involved also who can give us the requirements that we should meet. It's not about engineers coming in and deciding the requirements. So the final end users, the experts in the domain, the caregivers, must provide us information, and we're giving them language to describe situations in the home. And for this, I won't go into too much detail, but we've got a language that is development managed by Model, which is software where we define languages that are close to the users. These could be used by persons who are IT people to define these scenarios where we want to do testing. Here with some icons and sequences, we can see how if a person wants to go first to the living room and sit down and wait for a while, then get up and do something else. We can define scenarios of this type using different types of models. And then finally, after using different scenario descriptions, we can automatically generate more complex scenarios. Here we can see that there are 2 avatars, and one is the caregiver, the other is the person with Parkinson's disease, and there's the Android phone, and the Parkinson affected individual falls. The phone detects this and sends a message to the other person so he can go and help the person who has fallen or call the emergency systems, whatever. But in this type of environment, we can test these applications. It's not just first applications here in the sensors, with the sensors where we're using Android devices. We're also testing the control system that would be above this at home. That's the idea. So the advantage here is that with this type of language, more people can contribute to the development of these systems. And we're trying to achieve in this second stage of the project the creation of a virtual collaborative platform on internet where different types of persons can collaborate in the development of these solutions. We could have experts in domains who define this type of program, and also we could have persons who are just watching the simulations and they take note with labels and say, well, here I see that something's missing, or perhaps here we'd have to add in another function, or maybe this behavior would occur if we did it this way. And therefore, we could have artifacts for communication, simulation, or diagrams that we would allow the engineer to further develop the system, and everyone can then test it. So that way, we would have development where the final user's participation would become more and more important. That's what we're looking for. If you want more information, here you have the web page on the screen. Thank you very much. Thank you, Juan, for your presentation. We'll move on to the turn of questions now. Any questions? Well, I would like to ask you if this is really, I think you're coordinating with the University of Murcia, is that right? I think, well, on the one hand, we've got this program is in collaboration with the University of Murcia. We're looking for partners in Europe and for financing too. And anyone interested can get in touch with us and we can talk. We've also undertaken this project in collaboration with the Parkinson Association of Madrid, and the Complutense University has a group called FADIS, which are family members of persons with disabilities, and they are quite specialized with us in neurological terms of working on neurological diseases. And in Holland, we have been working too on tools that help us in Holland, not Poland. We've been working on tools. Well, your tool, I understand it's across the board and could be applied to many different situations. Any other question or suggestion? Well, on to the last presentation, which is going to be given by Juan Luis Carus. He is from Active, monitoring of as anomalous situations in older people. Mr. Carus, here on my right, is a doctor in industrial technology by the UNED University, and he has a doctorate in technology, industrial technology from the University of Oviedo. He has worked in Fundación CETIC. His main specialization is the use of ICTs for viable computing. He's participated as a researcher in several regional and national and European projects and has published internationally and had made a lot of publications based on research in different fields. Thank you very much for the presentation. As Ramon mentioned, I'm going to give you a presentation of a project we've undertaken called ACTIVE. It's monitoring behavior of older persons to detect anomalies. I'll talk about the trends that we have and the current situation, and then we'll go in to see what this project has all been about and the experience we've undertaken and realized. This is something we've been talking about over the last days during the Congress. We've been observing that we have an aging population, increasingly aging, and this resultingly has caused an increase in the need for assistance and health care. And the ICTs are a good alternative to develop systems for assistance that can prolong the user's life at home, improve his quality of life, and also help caregivers, doctors, and informal caregivers as well. In this work, the aim has been assistance to older persons and detection of any anomaly in behavior of the older persons or their caregivers. And we are talking here about changes in the user that are not expected given their routine. For example, if someone gets up every day at 8 a.m., if one day that person gets up at 11 a.m., that would be an abnormal behavior, and the system would be able to detect it. In the state-of-the-art situation, there are many different trends from when it comes to monitoring persons and looking at systems of assistance. There's a lot of personalization, a lot of commercial services involved, and we would like to highlight two. The service known as the panic button, which the user wears. And this device has a button he can press when he needs help. And there are other services, especially at commercial level, that are aimed for the sensors to be used to detect problems in the user. And if we have a DAFO matrix we've used over the development of our project and other times, it helps us see that the systems of assistance aren't always adapted to the requirements of the users. In the case of monitoring of medical variables, we need the users to be familiarized with the technology and be able to use this type of sensor. Also, we think there are many solutions in the market that are good, very good, but might be too specific for certain pathologies, and oftentimes use technologies that are not very mature, and the users don't end up acquiring enough information to be able to use them properly. But there are clear indications that there are many things out there that are good for assistance that can help us improve their life quality. And since the population is aging, it's clear that ITCs can be a big part of a good aging process. We need a measuring system that will be adapted to the user. We need a method of measuring, modeling, and a method of detection of those behaviors that are abnormal. Now I'll start off by talking about each of the methods. I won't take too much time to go into technical details, but I'll just give you an idea of each method. The measurement method uses a sensor that measures the movement of the human body, the physical activity. And this is any movement of the human body that results in an expenditure of energy. We measure also this and get a new magnitude that up until now was mainly used in other types of work. This new magnitude is called JIM, and it's based on 1 hertz, and we calculate the derivative, the jerk, to get this measurement every minute. For every minute of the user's activity, we would have a result. And using this new magnitude, JIM, then we get the behavior model to establish the routine of the individual. And the state-of-the-art would mainly be based on looking to see what the user is doing, if he's eating, walking, and we use all these activities to build the routine, and we do this in an automated fashion with statistics so that automatically and adaptively, having made measurements the previous days, we get the right parameters for the user. And that way we're able to detect all the abnormalities. This detection is based on calculating the difference between the measurements and the routine, and in the construction of a valuation based on diffuse logic. And summarizing all this a little bit, what we end up with in our system is a continuous signal. Zero value would be where behavior of the user is normal based on his routine, and a range that would be -0. We would see that there is some abnormality because the person is not as active as expected, and a positive value if it would be when there's more activity than usual, than is expected. And in the experimental phase, we've worked with a watch-type device, and here we've implemented our method of measuring the JIM. We have a PC we've given to each individual, and they have it at home, and that PC connects itself to the watch and downloads the watches or uploads the watch's information to us, and then we can use that to calculate the routine and the anomalies. In the experimental phase, we worked with 4 users over 60 years of age. We monitored them during 3 months' time and in a real environment, using the watch, and we asked them over those 90 days to wear the watch 24 hours, 7 days a week. If the user slept with his watch, we would say, sleep with this one. But if they didn't sleep with their watch normally, we would say, you don't have to sleep with this one. We just wanted him to use this like another element of his normal life. And the user would tell us the activity that he usually undertook, and if the user was undertaking no activity or little activity or high activity, we would see this in the data that we gathered. And we could validate the method proposed by the ACTIVE project based on 3 projects: reliability, if we were detecting the anomalous behaviors, invasiveness, if it was too invasive or not, and autonomy to validate the lifetime and the features of computational features of the device. Regarding reliability, we had 100% reliability during the 360 days of experimentation. We noticed 56 anomalous behaviors, and those 56, those were based on the activities taken out by our individuals studied. So how many times a day did the user wear the device to be able to realize if he was wearing it or forgetting to wear it or whatever? And as an average, he was wearing it 90% of the expected time. That 10% was mainly due to the time that he was sleeping. And if he was using it with the activities that were water-based, that's normally when they wouldn't use it.
And there's also situations when they decided not to put it on if they were going to go to a fancy dinner, for example, or similar situations. We've also assessed the autonomy. We realized how many days or how much time have we wasted because of autonomy-related issues. And the value is rather high because 10% of the days are not registered, mainly due to the lifetime of the devices, also the battery life, because every 15-20 days, depending on users, batteries had to be replaced, and that had to be done by an expert because you needed a screwer to remove the screws. We hadn't contemplated this issue. We hadn't contemplated also that they would spend some time in their second home, like for example the holidays home, and we lost information because the information wasn't uploaded on the computer. By way of conclusion, the active project allowed us to detect anomalous behaviors with no interaction by users, adapting it to their own characteristics. The migration was done in a real environment for 90 days with 4 monitored users. The accuracy was very high, it wasn't very invasive, and the autonomy was very low, unfortunately. We would like it to be higher. Perhaps one of the solutions would be to use some energy harvesting techniques. Going forward, from GTIC, we would like to validate the system by making it wider with more users. We would like to send automatic alarms to users and especially to caregivers to validate them. And last but not least, we would like to design an ad hoc element. We have carried out different focus groups. We would like to therefore design a smaller device, as small as a 1 or 2 euro coin, whose battery life could be several months, therefore fostering greater autonomy and being less invasive. And being so small, the device could be included in different garments, for example. If we are talking about a gentleman, an elder person who's always wearing his watch, just to embed the new device on the already existing watch. If, for example, the user is always wearing his glasses, to incorporate it on the glasses. So these are some of the ideas we're working on. And last but not least, just a few brush strokes on the active project of the Technological Center, partly funded by one Asturias-based funding program for R&D centers. In the 20 and 20 horizon, we've reached the score 6. We have to modify the protocols we're currently using for the exchange of information. The active project is part of my thesis, that was presented this year in the Distance Learning University of Spain, UNED. Thank you very much for your attention. Thank you. Thank you very much for your presentation, Juan Luis. Without further ado, we are now going to start the Q&A session. My question is twofold. The most important question is, do you take users into account? Are you user-centric? Do you think about users, or you think about their relatives? Users are very vulnerable. Or are you rather designing artifacts or devices for their relatives, who are very much concerned, of course, but who want to control their relatives, who want to minimize the risk? So I'd like to know, are you user-centric, or do you focus much more on the families? Would you like to answer this question first? Okay. In the ACTIV project, we've cooperated with different users, associations, but also associations for caregivers and doctors, in order for all the needs to be fully aligned. This is a continuation of other projects after a thorough study of the ICT devices needs to cover the needs of the users, really. So, indeed, yes, we are taking the users' needs from day one. This is one of the primary factors in our project, to have full involvement of our users, those who have to validate it before actually implementing the solution, because the users' associations are paramount. Oftentimes they tell us that, yes, they receive devices and solutions that at the end of the day, after a very short period of time, they just leave them in a drawer, in an empty cupboard, and they forget about them. So we need their insight, we need their feedback, and they need to be fully involved in the validation of the device. That's why I said that, yes, we do it on a web-based technology, but perhaps someone can show them the solutions and to validate them. And last but not least, if users are elderly people, they are very dependent, aren't they? And they have very limited income on average. This is a software platform, right? On both cases. Won't you rather have a free access platform? That is my question, really. It depends on whether they are open hardware, open software, or open source. In any case, in Europe, a vast majority of older individuals, they are retired, they have paid out their mortgage, their children are already working. That applies to some part of the Europeans, but others not. Well, the answer, I don't have the clear answer to this. As far as your first question is concerned, what is the role of volunteers in the design of platforms and services? In our projects, we involve them from scratch, from day one. We involve the users, we involve caregivers, and at all stages we collect information. And then we do the first functional design, and in that moment, then we move on to the second stage. to ask the technicians if what we designed is correct. After which, users have to be involved once again, and they validate in every single stage not to lose track. There's one thing to have a user who lives on a first floor and a user who lives on a fifth floor. So in order to do this assessment and the design of a technological product, we need to bear in mind social aspects for them to do the design. With regard to free software, yeah, it should be open and it should be free software. In the Red Cross, we work with socially vulnerable groups, and they are digitally vulnerable too. They should have access to the platform, but usually behind the platforms there is social caregivers, volunteers. They have to answer the phones. There's a service of ambulance in case of an elderly person tripping over at their houses. So it's going to be complicated to have an affordable service or free service because there's a lot of things behind it. I beg to disagree. Social entrepreneurship should have a sustainable and affordable business plan to give and to receive, otherwise it won't be sustainable. When I say free, it's just free for users, of course, not for entrepreneurs. I think that should be the challenge. I found your presentation wonderful. There is a third way, really. If we want to promote social businesses and social entrepreneurs, it had to be a win-win. It has to be a win-win for entrepreneurs and for users. But we also have to involve the social services. There should be free software. Same as it happens with certain care services, home care services. We'll have to come up with a specific formula for this. But I found your point very, very interesting remark indeed. Any other questions? Yes.
Sí. Bueno, en relación a lo que dice Ramón Celer, estoy de acuerdo. Yo trabajo en temas de políticas sociales.
I agree with Ramon. I work in the field of social policies. We have to become very imaginative. My question is the following. I didn't quite understand the field work you do. Is it with only for individuals, but only 4 individuals are involved? I think it's very little indeed. Because as Ana said, and it's very complex really. Because from the methodological point of view, if we are working in a different discipline, we have to be careful with methodology. So this is not an adequate sample. 4 individuals only? Too little. It doesn't reflect the situation. No, really. Are they men, women, from which social background? For which target are we working? Because we're measuring certain variables that are completely different depending on the individuals, and perhaps the results give a blur image of the reality. I fully agree with the approach, and I appreciate it, and I work in the field of social policies, and I'm thankful for that, because this is an existing need. But if we design something, we have to design something that's badly needed, and I apologize for the criticism, but sometimes, to be honest, the methodology is important too. We have to work in cross-functional teams. We have worked with 40 users. It is an independent method to assess the routine and one last method to detect the anomalies. With the 4 users, we have carried out a very long research project. There's one woman and 3 men trying to reflect most social groups, but again, I agree with you. It's a very limited number of users. Too low, indeed. We just wanted to have certain preliminary results. Now, with this new device, our goal was to try and do an experiment which really gives us more accurate results, larger results with greater number of users. But the problem with autonomy is that we could not expand the experimentation field. Let me give you my opinion about all these presentations, please. Everyone in this industry knows that all these developments and the ulterior acceptance by users requires the full involvement of every single stakeholder: researchers, developers, therapists, doctors, social workers, and most undoubtedly users, who really need to put their needs on the table. And those would be the guiding principles of our project. That was one of the mistakes we made at the beginning, not to bear them in mind. I can be an IT expert, I can be an electronic expert, but I'm not familiar with blind-sighted people. And the ONCE Foundation opened my eyes to this. Most entities request this, but even if it is not requested, I think this is the only way to operate. It is very difficult to launch products and services and to sell them in the market, but there's a very long process behind it, behind every invention, behind every project. The papers that have been presented today really show that technology can really cover some needs and meet the needs of the elderly. Okay, they can really solve their day-to-day realities, their day-to-day needs, their day-to-day clinical needs, and even solve certain emergency situations, such as an elderly person falling over on the houses. And Anna said at the very beginning of her presentation, this is all about relationships. Solitude is one of the main problems facing this target population, and with programs like Enredate, Tangle Up, or Go and Chat with Your Colleagues, I think these can really facilitate their lives. I'd like to ask a question to everyone here today. Do you think this is going to be implemented in special housing programs for the elderly? Do you think this could be present in, let's say, 20% of the homes? Do you think there's any hurdle to implement them? Enredate that I presented initially. We had the possibility to present it in different provinces. We were capable of defining what was behind technology, all those dynamics that were highly encouraging the social participation, the role of volunteers, among others. I realized that the expansion of such a service is going to be a reality because it's already going forward. The Red Cross Foundation, in cooperation with the Technos Foundation, are increasing their work. What are the hurdles, you asked? Digital literacy. Gender literacy is also important. The policies have been very positive, and it's also true that the user's profile changes because we were slightly reluctant to use certain technologies with the elderly, but now it's becoming easier, more user-friendly and more accessible. From the technological point of view, we're talking about telecommunications. Therefore, with telcos, you really need a minimum quality. You need to gain access to the internet. You need a technological device as well. It's a very thorough question, so well, I fully agree with what Anna said. Shortly, but surely we are steadily incorporating them in at the home. But we need political support too. We need the full involvement of the public administration in fostering and promoting this type of solutions. Said support is paramount for these solutions to be fully integrated in a wide manner. A lot of steps have been taken forward for the development of these platforms, and devices are cheaper and cheaper now. The smartwatches and the smartphones are cheaper. It's not like before, because we had specific devices just for a niche group of people. No, it's widely spread. And it's low cost. That's the primary goal, really, for a full integration. This is the end of this session. I'd like to thank the speakers for their wonderful talks, for their effort, and for participating in these presentations. I'd like to thank all the attendees and the support personnel, all the technicians, the sign language interpreters, and the other interpreters. Thank you very much indeed.